All right, ladies, I hope you're having so much fun. Snow day extravaganzas. For your lesson today, I am going to ask you to take some notes. So, step one, you are going to watch video one because that's going to be a concept we're just about to talk about. And I need you to take out your notebooks. So, if you haven't watched video one, pausing here, go to video one. And if you haven't taken out your notebooks, you're going to hit pause here and you're going to take out your notebooks. All right, so we are going to discuss something called the vertical motion formula, and we're going to label this 5.4 vertical motion formula. And this formula was developed based on that video you just watched. It's the idea that whether or not a projectile is falling to the ground or if it's being launched and it comes to the ground, the time in which it is in the air will be exactly identical as long as your initial velocity and the height are exactly identical. So the horizontal distance doesn't matter when you're looking at the time. All right, so that's a really neat concept because it allowed physicists to develop an equation that will allow them to predict how long an object is in the air. And it takes into account three major variables: the acceleration due to gravity, the initial velocity, and the initial height. Okay, so this is what you're going to start writing down. You are going to write down this formula. It's going to seem a little scary at first. -1/2 AT squared plus VOT plus HO. And we're going to spend some time defining each one of these variables. Okay, so y is simply just the height. So y is the height. A is your acceleration due to gravity. A is acceleration due to gravity. And because of the fact that we take units of measurement arbitrarily, sometimes we use feet, sometimes we use meters, we need two conversions for the acceleration rate. So if we're talking in meters, then an object's going to come to the ground at an acceleration of 9.8 meters per second squared. I hope you remember that from science. And then if we're talking in feet, the acceleration due to gravity is actually 32 feet per second squared. All right, so depending on the unit of measurement. And then T, obviously it's time in seconds. Okay. V little o. So if you ever see this, this is called a subscript. And it just means your initial velocity, right? At 0, what's the actual velocity? So V is initial velocity. And then H sub 0 similarly is the initial height. All right, so take a minute, make sure you have each one of these down. You can hit pause if you don't. Okay, and now I want to look at an example problem with this. Okay, so imagine for a moment I'm launching a toy rocket. So I'm going to make a sketch of my toy rocket. My toy rocket is going to go up. It's going to reach a maximum height, and then it's going to come back down. All right. And I'm going to ask you two questions about this toy rocket. First, let me give you some data. I know that the rocket will be launched at an initial velocity of 122.5 meters per second. Okay. I'm also going to launch the rocket from the ground. So it's also going to be launched from the ground. I'm just going to write the word ground. And that would mean that my initial height is actually at 0, right? We talked about how ground always represents 0 height. All right, follow me so far? All right, so the first question I have is, Well, how long is this rocket going to be in the air for? So how long will rocket remain in the air? Now, you guys always ask me about spacing. I'm going to zoom out a little bit here. For me, and this is up to you, I'm going to look at those two examples side by side. So I'm going to put one on the left-hand side of my paper, and I'm going to put another one on the right-hand side of my paper. Up to you. Feel free to use two sheets. So how long will the rocket remain in the air? So I want to know, it starts at 0 height. I want to know, when is it going to come back down to 0 height? Okay, so here's my formula. Y equals -1/2 AT squared plus VOT plus HO. All right, so I'm going to start filling in some of these values. Because of the fact that my velocity is in meters, that means I want to use my acceleration due to gravity in meters. Okay, so what is half of 9.8? So half of 9.8 is -4.9. And then I'm going to carry down the t squared plus my velocity. My initial velocity is 122.5. And then I have no height, so I'm not going to put a value over here, right? It's being launched from the ground. That's a 0 height. I'm not going to put anything there. And I want to know, when is it going to come back down? So when is the output going to be 0? So I'm going to let 0 equal -4.9 t squared plus 122.5 t. All right, excellent. So now I need to solve it, all right? And I'm hoping that this 4.9 actually divides out of my problem. And it does. You'd have to use it. I definitely have to check it with a calculator. But if I divide each one of these values through by 4.9, actually -4.9, I want the t squared positive. What I'm going to get is 0 is equal to t squared minus 25t. And then it becomes a simple factoring problem. Looks like it's a GCF of t. And then we have t minus 25. So when is it equal 0? When my time is 0 or when my time is 25. So you can see that in your graph. It starts at a height of 0, and then after 25 seconds, it's back down on the ground. Pretty neat, right? So we can predict how long it's going to be in the air for simply by knowing what that initial height r is and what the initial velocity is. All right, so that is example 1. Leave that example 1. Now I'm going to move on to example 2. And for example 2, I'm going to use the same data, the VO of 122.5 starting on the ground. But this time, I want to know, will it ever reach a height of 490 meters? And if so, when does that happen? So I want a height of 490 meters. And my question is, when? All right, so I'm using the same data, which means I can start with this formula, right? My acceleration due to gravity is already substituted in, and my initial velocity is already substituted in, and because we're still starting on the ground, there is no height. So that's what I'm going to write first. Y is equal to -4.9 t squared plus 122.5 t. And I'm going to I want to know, right, when time is it the output 490. So I'm going to let this equation equal 490. And we know that anytime you want to solve a quadratic, you want to set it equal to 0. So I'm going to actually just subtract over this 490 minus 490 minus 490. All right, let's see what we got. 0 is equal to -4.9 t squared plus 122.5 t minus 490. Now we know that 4.9 divided evenly by each one of these terms. I think it divides evenly into 490 too, right? 100 times. So I'm going to divide through by my negative 4.9. And I get 0 is equal to t squared minus 25t plus 100. So you can check the math on that, but I think that looks good. And now I'm going to use factoring techniques, inspection specifically, to figure out when it actually reaches a height of 490. So let's see here. 100 to make 25. Well, I'm going to do my little math over here. 100. There it could be 25 times 4, or 20 times 5, or 10 times 10. And I already found it. There it is. Right? So t minus 5, t minus 20. So what does that mean? T equals 5, t equals 20. Well, both of these are actually correct. If we go back to the graph, what it's telling us is that after 5 seconds, so let's say this is 5 seconds, my rocket ship will be 490 meters off the ground. And notice as it's coming back down, it's going to reach 490 meters again. And we can predict that that will happen at our other solution of 20. And that's really this idea. It's like you could have 2 times. You might have 1, you might have none. But in this case, we have 2 times when it reaches a height of 490 meters. All right, so ladies, that is your snow day practice. That is your snow day activity, is just taking notes. When I see you in class again, we will revisit this concept. I do expect this to be in your notes, all right? And for those of you who would like a little extra practice today, if you're bored, I'll also post 2 practice problems online, but those are not due. That is not something you have to do. Your activity is really just taking notes on this section. All right, have a lovely day, ladies. I can't wait to see you guys when we get back. All right, bye-bye.